Welcome to the North Forge Discovery Series, everyone. My name is Tina Lee, and I'm the Marketing and Events Specialist here at North Forge. For today's webinar, we'll be learning what steps to take when integrating artificial intelligence and machine learning into your startup. Before we begin the webinar, we acknowledge that we are meeting virtually on the ancestral lands of Treaty 1 territory, the traditional gathering place of the Anishinaabe, Cree, Oji-Cree, Dakota, and Dene people, and the traditional homeland of the Red River Métis people. For those of you who are new to our webinars, North Forge is the innovation partner for the province of Manitoba and an incubator accelerator supporting growth in the Canadian science-based, technology-enabled, and advanced manufacturing startups from the ideation stage all the way through to acceleration. We fuel Manitoba's innovation economy by providing entrepreneurs with industry-leading mentors, award-winning growth coaches, and rockstar subject matter experts in our new 4-stage Founders Program. North Forge also has North America's largest nonprofit, publicly accessible fabrication lab located right here in Winnipeg's downtown Exchange District. The Fab Lab has in excess of $3 million of advanced manufacturing equipment that has helped more than 3,000 entrepreneurs develop over 7,500 prototypes since 2011. The North Forge Discovery Series are free events that we host in conjunction with and promotion of our Founders Program. If you have a business idea and would like to find out more about our Founders Program, please visit our website or send me a note and I'll get you in touch with our programming team. I'll place the contact information in the chat shortly. And with that, I welcome Griselda Sukmoro and Omid Hajjanasat, who are from ISAIC at the University of Alberta. They help businesses, innovators, industry collaborators, instructors, and learners accelerate and transform their artificial intelligence and machine learning projects to accelerate commercialization of AI solutions across Western Canada. Griselda is a tech marketer, has graduated from the MBA program at the University of Alberta. Her role as the client development specialist at ISAIC mainly focuses on partnership building, business development, and marketing planning. Omid is a graduate with a master's in science in software engineering at the University of Alberta. As the machine learning and client analyst at ISAIC, Omid is passionate about HPC programming and how to apply machine learning to business problems. And now with that, Griselda and Omid, the floor is all yours.
Thank you, Tina, and welcome everyone. Let's start the presentation right now. I'm going to try to share my screen, so let me know if you already find it. Hold on. So yes, I hope you can see this.
Yes, we can see it perfectly.
That's good. Okay. So yes, so before we start anything, actually, I want you to participate in a poll first. So if you can click this poll or not click, go to the website pollev.com/isaic712. And then I'm just gonna go with this activated result. I'm just gonna look if, so there's a question here. What game did AI play in 1950? Is it A, Go, B, poker, C, tennis, or D, chess? So if you go
Griselda,
to the poll, yes?
I'm really sorry. Could you pop the link into the chat so people can
That's what I was thinking too. Okay.
Thank you.
Okay, so let me try if I can. There you go. I can put this. There we go. And then I'm pretty sure they will ask a little bit if you want to register, and you can skip that. Oh, yes. Okay. So you figure it out. So yeah, go for A, B for poker, C, tennis, and D for chess. So which one is it? I'm just going to wait for another minute, I guess. Sorry, I see a chat here. Yes, thank you.
Yeah, we'll wait a couple minutes because there's a few people that just joined us.
Yes, that's what thank you, Tina. Yes.
You're welcome.
Yeah, so if you go to the link, I think you can just skip the registration and then you can skip the name as well. Okay. Oh, we have a very interesting statistics here. Oh, okay, sorry. Yes, okay, so I think we can conclude the game for now, and the correct answer is actually chess. So congratulations for everyone who choose chess. That is correct. Okay, so I'm just gonna deactivate that one, and then let's start again with the presentation. So yes, it's very interesting how games, you can actually play it with AI, and they can actually learn how the right movements to take, and actually might have the chance to win it over. So let's see more of the agenda of the presentation today. We're going to talk about examples of AI, and then things we need, that are essentials to adopt AI, and then the steps to adopt AI, and then finally where ISAIC comes in. And so for the examples, I'm going to mention Precision AI from Saskatchewan. So they built AI drones, which essentially the drones fly over the crops, and then they will precisely spray towards the weeds to prevent so it's essentially herbicides. And in that sense, they stated that they forecasted up to 85% savings in herbicides. So that's how AI can help in terms of cost reduction. And then the other company I want to mention is Clinisys. Clinisys is based in Alberta, and then they develop electronic medical records. So it's more, that's what we call EMR. And then with ISAIC, what happens is that they mentioned that their analytics in AI and ML significantly develop up to 50% of business product lines from Clinisys. So AI can help in terms of agriculture, in terms of healthcare, and different industries nowadays. And this is why we're interested to learn more about AI adoption. So next, we're talking about the essential things. What do we need in terms of AI adoptions? And then the first thing we need is data. We need data that is representative of the current situation. So data that is, for example, comply to the privacy concerns, and then data that is correct, that for example, you will need to have data with the time based. So you will need to include data that is not missing. And then other than that, we need human competency. In essence, it means that you need to hire people who have the IT skills, the AI skills, they have the domain understanding, and also you need the computational resources. By that, I mean, for example, the storage, like cloud storage, or maybe hybrid infrastructure, which the challenges might be that there might be hidden costs, which we will talk about later. But these three are the factors that drive the application of AI. Okay, so now we're going to dive into the steps, which is the data hierarchy of needs. I will pass it on to Omid.
Okay, thank you, Griselda. So, hello everyone, my name is Omid. As mentioned, I'm the machine learning and client analyst at ISAIC. So in this slide, we are going to see the data science hierarchy of needs. So this is as you can see, these are different steps in adopting AI and essentially building an AI solution from the data that you have. So in the first step, we see that we need to collect data. So it includes sensor instrumentation, logging, and a bunch of field work. Then the next step would be to move and store that data. So you can also incorporate these steps. So the lines between these terms and these steps isn't really well defined, or isn't a line that essentially is not something that they can essentially be mixed. So these steps can be all done together. So you can collect and move the data at the same time. So the next step would be exploring and transforming that data. So you need to clean that data, and you need to, for example, fill in missing values. And after that, you'll be working and aggregating multiple data sources together, perhaps building better training data sources, and making different metrics from the data that you have collected, and essentially pre-processing the data for the learning and optimization step that we have. So in that learning and optimization step, we do different iterations of machine learning, perhaps setting different hyperparameters and finding out the best model for the data that we have collected. So that's how we wind up with an AI deep learning solution. Important thing is that these steps aren't necessarily sequential. So you might have uh, cyclical steps that you collect data, you clean it, you train model, and then you think that, hey, I need more data, I need better data, I need data with better resolution. So you start everything from the beginning. So next slide, please. So the first step that was the data collection, essentially. So this here shows that the expected growth of data collection and data generation by year 2025, but by different regions around the world. So you can see China is expected to go roughly 40 zettabytes, so which is 1 million terabytes data generated in 2025. You see rest of the world, you see US, you see Asia Pacific and Japan, excluding China, all showing an uptick in data generation, meaning that essentially data is going to be the new gold rush of this century. So please, next slide. So essentially data can be from multiple sources. And in this day and age, it is multifaceted. So data is generated and collected by operating systems, mobile applications that you have running on your devices, IoT ecosystems, business partnerships that you have, for example, fintech data, multimedia data, social media data. So an aggregation of all of these can also be used to build machine learning applications and AI solutions. And the good thing about this is that using multifaceted data broadens our view and our information about the environment that we want to build, and essentially helps us get more optimal solutions. So next slide. So the challenges with these data collection can be essentially 5 factors introduced by the 5V scheme. So the V stands for the first character of all these words. So the volume of the data is going up. The velocity of the data would be challenging because with, for example, social media, you are getting millions and millions of transactions, or for example, liking the pictures, looking at the pictures, trying to find out different nodes in that environment. The variety of the data, as we mentioned, data is becoming multifaceted, and every day we are getting data from different sensors and different modalities. The veracity of the data and the value of the data. So these are the different factors that essentially make data collection a challenging task. Next slide, please. Also, other challenges that are not included in the 5V scheme can be the storage of the data, the privacy of the data. So if this is a medical care kind of scenario, if you're collecting data from patients, you're essentially endangering their privacy and risking exposing them to hackers or to unwanted privacy intrusive actions that can be taken on their data. So you have to be really careful about what you share. That's why you see healthcare solutions or some type of other companies don't share their clients' data. So data collection can also be hindered by the reality on the field or in the field. Maybe you want to collect data from the, I don't know, trees in the jungle, but then again, trees are in the jungle. So you don't have good broadband internet connection, and then you might have lack of internet connectivity. So it makes that challenging. You need people to be in the field. So the cost of the expertise as well goes up because you need to pay people to go and maintain the sensors, to look after the grid that you're collecting the data with. So these all are challenging factors in the big data and collecting data. Even a small data in a small scale scenario might prove challenging due to these reasons. So next slide, please. So before this, I want to give it back to Griselda to poll a question.
Yes, so if you can go back to the link, and I'm going to copy paste it again into the chat. So I have another question for you. So let me see if, oh, sorry. Okay. So yes, the second question is, so this one you can yes, actually people already put it in. So which cloud provider have you used before? So let's see. People have mentioned Google, Microsoft, Cloud, AWS, ISAIC. That's nice. Google, okay, twice. Another Google, I think Apple. Oh, there's an Apple, and then Azure, okay. AWS. And for those who don't know, AWS stands for Amazon, I think. So Amazon Web Services.
So I think the larger the text font is, the more frequent it was suggested. So AWS and Google were the main to go, as well. Google essentially is the biggest one.
Yes, that
The
is correct.
Microsoft Azure is, and Apple and Isaac essentially are uh, least frequent ones.
And not to forget, there's also someone who hasn't used anything, so that's okay.
No?
That is why we are learning today. Okay, so thank you everyone, and let's continue to the presentation where we will actually discuss about the differences between the cloud providers,
Yeah.
or rather the cloud resources out there. Okay, go ahead,
So in
Omid.
terms of, thank you. So in terms of storage, there are different options for infrastructure and data storage solutions that you can get out there. So either you can go use your local resources. So for example, you can buy different infrastructure that you host on your premises, or either you do co-location with other organizations. For example, you go to the University of Alberta and you ask them to host a server that you bought. But the main issues, the challenges with this co-location or main ownership of the hardware would prove to be the high cost and the high upfront cost, because you need to buy the hardware first, then you need to have some folks looking after it, because essentially the hardware needs to be maintained, needs to be updated, and a solution needs to be built on top of it for storage. And also the cost, and due to the speed of evolution of hardware, it would be obsolete soon. Another solution would be to go with enterprise cloud providers. So sometimes going with Google Cloud and AWS would prove to be challenging, because you essentially become locked in a certain platform, and your solution essentially is only locked in that platform. So any price changes or any policy changes would affect your solution and organization, and inflict the cost of switching and moving, because, for example, Google and AWS have hidden charges that include egress fees. For example, if you put your data in their storage and you want to take it out, they charge you based on the gigabyte of the data that you move. So, and also the support that you get is not really handheld, so it's a more automated support that you get with these resources. For those of you in the academia, you can also go and use research compute platforms. Fortunately, Canada has a lot of research compute capabilities and organizations. For example, Canary, Westgrid was one, and also the new Digital Research Alliance of Canada, or Drake, so I don't know how the abbreviated version very well, but the issue with that it is that it's mostly for researchers. It is scheduled, and due to the limited amount of access and resources, there is some sort of competition involved in getting resources or getting good resources on demand. There are some local providers like Cybera in the province of Alberta, and ISAIC also in the province of Alberta, that they um, essentially emulate enterprise solutions, but at a local scale, and at a different scale compared to AWS and Google Cloud. Our resources at ISAIC are relationship based, so we don't have any lock-in or hidden charges. For example, if you grow with us and then you want to move to Google Cloud or AWS, there are no hidden charges. You own your IP. And the risk of maintenance and people costs would be way less than what you get from on-premise solution, and the high touch point support would be more than what you get from the enterprise solutions. So next slide, please. So the next step in the data hierarchy of needs would be data transformation and aggregation. So please go to the next slide. So the collected raw data that we collect and then store essentially needs to be transferred and cleaned prior to it being ready for machine learning and artificial intelligence or building neural network models. The reason is that, for example, you get noise in your data, you get missing values, or sorting your data would make your algorithm faster to converge. So there are these different things that would require data scientists to do this step. So this step would require your company or your folks to essentially do some data scientist operations on the data that you have. And let's see why transformation matters. So the transformation and aggregation and then cleaning of the data, maybe denoising it, maybe filling missing values or sorting the data would contribute to a higher data fidelity and quality. Also, it would guarantee a faster path to the optimal solution when you're training for your model. And there is a general rule in the machine learning community saying that if you put garbage data in, you get garbage solutions out. So garbage in, garbage out essentially points to the fact that if you have essentially noisy data, what your model learn is noise. So you need to denoise and you need to clean your data. So next step, please. Also, data aggregation and fusion from multiple sources helps us to battle biases and widen our scope of understanding from the real world. For example, if done improperly, inference biases can happen and cause irreversible damage. For example, if this is a medical situation that you're training a neural network for, there would be a life and death decision being made. So that's it would incur a high cost if it makes the wrong decision. Or for example, if you're fitting your model and if you're training a model for urban planning or socioeconomic decision making, if all your data is from real world and without any proper cleaning or understanding of the data, you see gentrification. So if you look at municipalities that promoted gentrification and you train a model, your model would promote gentrification. So that's another fact that you have to be careful incorporating multiple data sources and essentially aggregating them and fusing them together. And also judicial cases. So we have this bias in conviction rates based on different ethnicities and races. So if you directly incorporate that into your model, it would also cause the biases in conviction rates. So we have to be careful about what data we train our models with. So next slide, please. So one of the final steps of the hierarchy of needs would be building and optimizing the data. So when you collect your data, find a solution to store it and then clean it properly, we get to the point that is the capstone, is the end of the hierarchy of needs. And we are at a place that we get to train our models, pick the models that we want to train, and then maybe go start from the beginning. So as we mentioned, this is not a sequential kind of hierarchy steps to an AI solution. It might be cyclical, because you might understand that you need better data or you need the data with a different resolution. So you need to start from the scratch. So essentially, at this step, machine learning developers or data scientists use AI frameworks and APIs to find and fine-tune the best model and algorithm for the scenario that you have. The reason that this might be challenging is that there is no one size fit all. So essentially, there is no universal solution. At this step, we fit the data to the model. With deep learning and neural networks, it is best to train them on GPU optimized hardware or tensor processing cores, because it would make the process faster, as these solutions are data intensive and require a parallel hardware solution to accelerate them. Then we go into the test, evaluate, and repeat stage where we test different models, essentially fine tune them and evaluate them and repeat the process to come up with the best solution. So next slide. So there are different models, as we mentioned at the beginning of the presentation, about the difference. I think it wasn't recorded. So the question that we asked was, what's the difference between AI, machine learning, and deep learning solutions? So here you can see, for example, starting from machine learning includes algorithmic techniques such as statistical models or statistical learning techniques that are mostly CPU intensive and have low complexity to train them. So for example, you can use them for housing market prediction, fraud detection, or disease detection. But when you go into solutions that use deep learning or neural network training, you will be needing GPU or higher performing computing solutions for this stage of training. So these techniques include deep learning models, time series or gated and graph-based models, which both need CPU and GPU solutions and are very high in complexity to train. These include, for example, natural language processing solutions that you might have, like such as GPT-3, or recently DALL-E 2 came out, which is a mix of computer vision and also natural language processing. So these are the differences between deep learning training and machine learning. So in machine learning, you might mostly need CPU, but if you want to get away with deep learning, you need good hardware. So that's why there is a need to scale to cloud providers. So next slide, please. So I'll give it back to Griselda to continue with the key learnings. Thank you.
Thank you, Omid. And yes, one more time, we have the final poll. I just want to ask you a question here. So if I can, oops, sorry. So let's see. So the question is regarding the steps of adoption. Oh, sorry, not this one. I haven't changed it. There you go. Now you can see it. Is it true or false that the first AI adoption stage is cleaning the data? So one person, or maybe I don't know how many said false. Some said true. Okay. Okay, it's still moving. Okay. Yes. So the correct answer is actually false, because the first AI adoption stage is collecting the data. So here, it's the first one is collect. Cleaning is part of the third, but of course you can kind of like going back and forth. After you collect, you need to store it, you clean it, and then you collect again. That makes sense. Okay, thank you for participating for that one. So what did we just learn? So first, adopting an AI is a multifaceted challenge. It requires IT, AI skills, and other domains as well. And then the second thing is that to enable AI and ML in your organization, you need the business understanding. So what it means is that you need to know what problems that you want to solve first. So for example, if you have a grocery store, perhaps the question would be, okay, so out of all the products that I have, which one is the most, which ones makes more sense to give discount? So you have a problem statement over there, and then you start collecting the data and then store it and etc. So that's very important to have. And then finally, the pyramid encapsulates the essence of steps required to making an AI-enabled organization. So where does ISAIC come in? So a little bit about ISAIC. We are a nonprofit. We are housed at the University of Alberta. So we are based in Alberta, but we serve all Western Canadian SMEs and startups, as well as, SMEs and startups who has AI projects. So what we do is that we offer or we provide the IaaS, which means infrastructure as a service, as well as we connect you to the experts and we connect you to the innovation ecosystem as well in Western Canada. And then how we are different. So here we have examples of Alberta-based organizations. So we mentioned previously Cybera as another local cloud provider, but I believe in Manitoba, it's MRNet under the Canary as well. And in Saskatchewan, it's SRNet, and then in BC is BCNet, if I'm not mistaken. And there's also AltaML and Amy. So AltaML gives us a turnkey solution. So someone would come in and basically ask, how should I adopt AI? And then they will give the overall solution. And then Amy focuses, or Alberta Machine Intelligence Institute focuses on building the human resources. So they have the courses such as ML 101, or maybe AI basic courses like that for data scientists and also ML experts. And then Cybera focuses more into the connectivity and also the data science. So they have previously data scientist fellowship program, and right now they're trying to change that a little bit, but essentially it's developing data scientists in the Western Canada, actually in Alberta for Cybera. And I'm not sure, but MRNet is also might have some resources available for you in terms of data scientists. And ISAIC focuses more into the infrastructure and applied knowledge. So the people who come to us, usually they want to test a proof of concept. And yes, so they're based in Western Canada. And you can consider us as your friendly neighborhood cloud because we're local, and also we are very customer oriented. So we have customized solutions, and then we have a customer service as well. So sorry, we have the AI garage, which means like we provide GPU, which is graphic processing unit, and CPU, core processing unit, and VMs, virtual machines, as well as the connection to the innovation ecosystem, the hub, and connection to the experts. And finally, the things that we want you to remember from us is that we're local and we're secure. We comply to the HACFAT. HACFAT is a certification, or rather a qualification. So the other thing is we're fast and scalable because you don't have to have the equipment there. We can actually adjust whatever the needs that you have. And then we have an expert support that is very high, high touch points. So it's very relationship based. And that's it from us. And if you have any question, you can actually scan the QR code of mine, or you can contact us at isaic.ca. Also, the email is here. Thank you. And I'll stop sharing for now.
Thank you so very much, Griselda and Omid. That was a wonderful presentation. We really appreciate you discussing all the steps that we need to take to incorporate artificial intelligence and machine learning into our startups. Your polls are awesome. I just love them. We have some time for questions. If you're comfortable, you can turn on your camera and your mic and ask Griselda and Omid. Or if you'd like, you can add your question to the chat and I will relay them to them. So floor is open to all of you wonderful people.
I have a question.
For sure.
We're currently using Google Cloud services, and I'm just wondering, when you're pricing out your services, how have you done so relative to, you know, the costs? I realize these are very scalable environments and nobody's needs are the same, so I'm not asking for a fixed price. But are you targeting something that's 70%, 80%? Are you equal? Is there a cost savings by coming to you?
So I can take that question. Sorry, I can take that question. Yes. So at ISAIC, the ultimate goal is to help SMEs and startups to succeed. So your success is our success. But the way we do pricing is more like it's depending on your stage. So for example, if your startup is just beginning, so the price would be different with someone who's already established, if that makes sense. And then in comparison though, usually it can be up to, for example, 70% compared to the market price. But again, like it depends on your situation.
Okay, thank you very much. 70% is significant. I'll reach out. Thank you.
Yes. Oh, okay. Yeah. You're welcome to reach out. Of course, yes, definitely. Yeah, if you have any questions and you want to, actually, the thing that I forgot to mention, we do also have trials. So you're welcome to try our environment, the machines for 1 month, and then afterwards you can decide. Mhm.
I guess I could follow that up with an additional question. So we've taken the approach where we're doing a lot of our machine learning in-house on a really strong GPU machine. And I'm wondering about the ultimate application of our use case. Does your infrastructure, does your cloud infrastructure also support, you know, the end games for these AI projects in terms of getting these solutions out to people, or is it strictly for machine learning and AI development processes? And then when you become commercial, do you branch out and go off on your own, or how far do you guys go with that?
So essentially, I can answer that. Regarding the GPU solution that we have, so let me start by saying that we price ourselves comparatively, but these are not cheaper solutions that we provide, meaning that our hardware isn't less expensive. Essentially, we have all the top performing GPUs out there. We have V100 GPUs. We have the new A100 GPU with 80 gig. So I don't know, but if you go on Google Cloud and you see and spec out a machine with A100 or V100, the pricing would be $2,000 to $3,000 a month. And essentially, so I wanted to say that the GPUs that we have aren't just gaming GPUs that we rig together. So these are very top performing GPUs. And regarding your question about whether you can also deploy with us. So as we procured more funding and we are also maturing because we are a startup as well, we are building that kind of business continuity into our infrastructure. So instead of using one server room and data center, we are branching into using 2 data centers. We are having a backup storage as well. So a petabyte of backup storage, complementing our already existing petabyte of storage at our server rooms. So we are becoming more and more kind of a solution that allows clients to rely on us for their deployment as well. But it all comes down to the terms of service that we have. So at the moment, the terms of service indicates best effort practices. We do our best essentially, but there is no, in the user level agreement, there is no mention of uptime, but we didn't have that many outages, or I can say the uptime wasn't like 80% of the time. It is all working, but I just wanted to mention that you can scale with us, but the user level agreement mentions best effort services for deployment.
Okay, thanks very much.
And
The reason, sorry, the reason I ask is our company, we deal a lot with satellite imagery.
Mm-hmm.
And so, you know, to be on a commercial cloud service when we scale, that involves a huge amount of data, it's a big task.
Yeah.
And I already feel that I need to go away from commercial cloud services because of the cost. Their cost scales as we scale.
Yeah.
So just a heads up for you guys that there's a niche there for you if you want to go into it.
For sure.
Because I don't have a solution to it right now.
No, that's correct. Yeah.
Thank you very much.
Sure.
Thank you, Paul. Does anybody else have a question for Griselda or Omid? You can pop it into the chat, or you can come off you can turn on your camera. Okay, well, thank you so very much. This is all the time that we have for today. We appreciate Griselda and Omid from ISAIC coming out today and answering everybody's questions and for explaining the difference between AI, machine learning, and all the steps that we need to do to incorporate them into our startups. And thank you, everybody, for being a part of the North Forge Discovery Series. We're looking forward to seeing you at future North Forge events. If you follow us on Eventbrite, you'll be notified of upcoming webinars before anybody else. I'll be adding the new events soon, and you can find the link in the chat. I'll pop that in. And if you have a business idea and you'd like to find more about the Founders Program, give me a shout and I'll connect you with our programming team. And my info's in the chat. And lastly, before we wrap up for the day, we'd like to thank our sponsors, Bell MTS, BitSpace Development, Boxtel Construction, Princess Auto, RBCX, Stu Clark Center for Entrepreneurship at the University of Manitoba, and TDS Law. And that's a wrap, everybody. Have a wonderful day. Take care.
Thank you.
You're welcome.